Hi, let's talk about the memory model. First question, what is the difference between the integer and int? Okay, so first of all, int has no generics, while the integer you can use as a generic type. So integer is 16 bytes versus 4 bytes on int. So it is very useful to use int when you want to save some memory. Okay, local int is stored on a stack as the value. The instance int is stored on a heap with the object as the value. So you must remember that the integers objects are stored always on a heap. So it will be more work for the garbage collector. How much memory does different types take on a disk? So objects in JVM for 32-bit processor is combined of 8 bytes of metadata and 4 bytes of class reference. For 64-bit processors, it is 8 bytes of class reference. Okay, so let's have a short look how much memory it takes for each type. So boolean is 1 byte, also true. We have short, int, long, and integer in boolean we have 16 bytes. So you see that int 4 bytes, integer 16 bytes. So whenever you can, use int to save some memory. Okay, so about the objects. The usage of memory for an object, to know how much memory, we have to add the memory used by each instance variable to the overhead associated with each object, which is typically 16 bytes. So let's see an example here. We have an object, we have a class date with 3 instance variables. Each of them are int, so we have 3 ints, 4 bytes each, so it's 12. And we have the overhead, which is 16. So 16 plus 12 is 28, so 28. But the memory usage is typically padded to be a multiple of 8 bytes on a 64-bit machines. So if we have 28 bytes, so it will be stored like you see on 32 bytes. So we will have a padding here, yeah, for the difference between 28 and 32. What are the different object sizes in JVM? So we have the shallow size, which is the object size without objects which it references. The deep size is the object size with objects it references. And very crucial for memory leaks finding is the retained object size, which is the memory size which could be free when removing this object with all of the objects which this object references. So it's vital when you want to find the memory leak because we order by this value. And the difference between retained and deep is that garbage collector cannot delete objects referenced by other objects. Yeah? Which are the different segments of memory? So we have the heap segment, stack segment, and a code segment. So heap segment contains all of the objects in the runtime. So objects plus their object attributes, so which are the instance variables. Yeah? You can see here all the objects are stored on a heap. While on the off-heap memory, we have the stack for each thread, yeah? And each thread has many methods, and each method has a stack frame created here. Yeah? So local variables inside the stack frames are referencing the objects on a shared heap. Yeah? And we have also the code segment, which is in the off-heap memory, and the segment where the actual compiled Java bytecodes reside when loaded. What is the difference between heap and off-heap memory? So we have an example here. We have a stack reference class with one first method, which runs the second method. And as you can see here, on a stack memory, we have each stack frames created for each method. So this is the off-heap memory and heap memory here. And as you can see here, we have a local variable, new car. So we have second here on a stack, which is referencing the object on the heap. And the same situation here. Okay, so we have here the heap reference class with an instance variable which directly references the heap object. What is the difference between heap and off-heap memory? So let's see what is heap memory. Two parameters to set the initial size of the heap for JVM. When you start JVM, you can put these parameters, XMS, XMX for maximum, for minimum memory. Normally we set around 1, maybe 2 gigabytes for a heap, depending how many objects do you have in your project. As we already said, on the heap we store objects, and we also store the string pools and static and instance variables. All are stored in a memory heap, shared among all of the threads, so it's not thread safe, remember. Okay, the heap is also divided into a new young generation and the old generation. The new generation is for objects which are new for the garbage collector and which die more often than the old ones. Die means that inside the old generation part of the memory, we store the objects which survived many garbage collector cycles. And on the new one, here are the new objects that only survived 1 or 2, for example. And the new generation is also divided into Eden, Survivor 1 and Survivor 2. So whenever the new object is created, it goes to Eden, then here, and if it still lives, it goes to all generation. What is the off-heap memory? So first of all, we have the stack memory and parameter for minimum XSS. The maximum memory we normally would set if we have, for example, 2000 threads for an average application, 1 megabyte per each thread, so it means that we will need 2 gigabytes of the memory on the stack. Remember that on the stack we have the memory for per each thread. That's why we have to multiply the amount of threads. So whenever you create a new thread, it will have its own stack created. All local variables, methods, parameters, and the exception handler parameters will be allocated on the stack. The objects themselves are stored on a shared heap, remember. So they are thread safe unless the reference is given outside the method. While the value for primitive time, the Java forces all local variables to be declared as final to keep local variables thread safe, since the reference cannot be changed. Each method called by a thread creates a stack frame on a thread stack. As soon as meta execution is completed by this thread, stack frame will be removed. Instance variables are not threads because are bound to the instance stored on a heap and may be accessed by two threads at the same time. Okay, as we have metaspace and code cache, part of the off-heap memory. Metaspace, it exists from Java 8, previously it was permgen. It is a native memory limited by your operation system, so you have to monitor it using your Unix command top. And it stores various metadata required by your JVM. The code cache is also crucial for JIT, Java in-time compiler. So you will know that if the memory is full, the JIT will stop working, and your code will not be optimized. So it will be 20 times slower than before. Okay, that's it. Thank you.